Hello class, this is Mr. Hart, and in this podcast we want to continue our unit on proofs and geometry and look at some triangle theorems, okay, or proving some cool things about triangles, okay. But before we start, we want to look at some ways we identify triangles, how we know what they are, and hopefully these are a review again from some previous math course, but let's quickly look at how we can identify triangles or the different types of triangles, okay. So there's three different types of triangles based on their angles. Okay, if we're looking at angles, there's acute triangles, obtuse triangles, and right triangles. Okay, and how we label them is based on their largest angle. Okay, so if the largest angle in a triangle is less than 90 degrees, it's acute. If it's larger than 90 degrees, it's obtuse, or if it is 90 degrees, then it's a right triangle. Okay, so you look at the largest angle, you look at the measure of it, and if it's less than, equal to, or larger than 90, you can determine if it's acute, right, or obtuse. Okay, so that's one way we identify triangles based on their angle. Another way we identify triangles is based on their side lengths. Okay, so then we have scalene, isosceles, and equilateral triangles. Okay, so for a scalene triangle, all the side lengths are different. Okay, there's no relation between the different sides; they're all just different values. None of them are equal or congruent. Okay. With an isosceles triangle, we have two different side lengths that are the same. Okay. So we usually have two sides we call legs that are equal in value, and then we have a base. Okay. So this leg would be equal to that leg. Okay. So an isosceles triangle, two side lengths are the same. Okay. Let's write that down really quick so we can remember. So isosceles triangle means we have two sides that are equal. Okay. In an equilateral triangle, every single side is the same. Okay. So this side is equal to that side, equal to that side. So we have three sides that are equal. Okay. And then in a scalene, we don't have any sides that are equal. Okay. But there we go. That's how we identify triangles based on their side lengths. So scalene has no equal side lengths. Isosceles triangles have two. And equilateral triangles have three. Okay? So there we go. So that's how we identify and classify these different types of triangles. So the question is, why do we worry about this? Well, it turns out that a lot of these different types of triangles have some very cool properties. Okay, so we're going to look at a property of isosceles triangles. Equilateral triangles have lots of cool properties. As you probably have learned before, right triangles have some very cool properties with the Pythagorean theorem and stuff like that. So we want to be able to identify the type of triangle we're using beforehand so we can look at those properties when we're doing the different proofs. Okay? But let's move on. So now we want to look at some theorems that we can use when we're trying to figure out properties of triangles. Okay? And these theorems we proved in class, but for this podcast we're just going to look at how we use them. And the first theorem is the triangle sum theorem. Okay, so we showed how we got this in class, but the idea of the triangle sum theorem is if I add up these different angles, okay, the angle measure of A, the angle measure of B, and the angle measure of C, which I'll write with little letters so we can see it. Okay, so the angle A and the angle of B and the angle C, the theorem says, okay, that the measures of A, B, and C, or these different angles, will all add up to 180 degrees. Okay, so A plus B plus C is going to give us 180 degrees. Okay, now this is a very important theorem that allows us to figure out these different angles in triangles, and so we're going to use this a lot, but that's the key idea. Okay, for any triangle, it doesn't matter if it's acute, obtuse, right, equilateral, scalene, whatever it is, okay, it will always have its angles add up to 180. Okay, so that's the first theorem we need to use. Okay, the next theorem is called the exterior angle theorem. Okay, and it's a similar idea, except now we have a triangle and we have a line that is coming out of the triangle like this. Okay, which gives us this exterior angle D. Okay, now there's two parts of the exterior angle theorem. Okay, the first part says that, well, D and C are a linear pair, they share that line, so we know that D plus C better give us 180. Okay, and that's pretty easy to see right there, right? Because they're a linear pair, that means they're supplementary. So the first part says that D and C equals 180. Okay, Well, we can also show by the triangle sum theorem that if we look at this situation, okay, and we're looking at exterior angles, we also have a relation between A and B and D, okay? Because A, B, and C adds up to 180, and C and D add up to 180, so D must be the same as A and B. So we also know that A plus B gives us D, okay? Or I guess I should write these in capitals since it's written in capitals there. So A plus B is equal to D, or the measure of D, okay? So this exterior angle is equal to these two inside angles, or what we would call remote angles, okay? Just a fancy term, but A and B give us D, okay? So that's the exterior angle theorem. So we have these two properties right here, okay? So that's also a very important theorem that we're going to use a lot as well. And then the last theorem deals specifically with isosceles triangles, okay? And what that says is for any isosceles triangle, okay, if we're looking at these angles down here, B and C, okay, the angles that are on the base of the triangle, or that side that's not equal, okay, on the base of the triangles, then we have the relation that B is equal to C, okay? So base angles are equal to each other, okay? And so this is a very nice property of isosceles triangles and can help us figure out a whole lot about the triangle, okay, because those two angles are always equal, okay? Another way we could draw this that sometimes you'll see is you'll draw the two lines, okay, like this, showing that those two angles are the same. But B is always equal to C, or the two base angles are always equal to each other on an isosceles triangle, okay? All right, so we got our three theorems down that we're going to be using for triangles. We got the triangle sum theorem, we have the exterior angle theorem, and we got the isosceles triangle theorem, okay? Let's try a couple problems to see if we can get this down, okay? So let's look at this one. So we got an exterior angle right here. We have this angle that's known right there, and we're trying to find the measures of A and B, okay? Well, we can use some properties of the exterior angle theorem to help us out, okay? Let's start with B. Well, we know that B and 143 are a linear pair, okay, from the exterior angle theorem. So that must mean that B plus 143 degrees must give us 180. Okay, so we can use that fact to find B. So we'll just minus 143 to the other side. Okay, that will give us B is equal to 180 minus 143, which means that B must be equal to 37 degrees. Okay, so there we go. B is equal to 37 degrees. Now we can use the triangle sum theorem to figure out the measure of A. Okay, because A, B, and 81 degrees are all inside the triangle, so we know that if we write this out, that A plus B, which is 37 degrees, plus 81 degrees must add up to 180 by the triangle sum theorem. Okay, so now we just minus those two over, and we'll put that in our calculator. So 180 minus 37 minus 81 will give us that A is 62 degrees. Okay, and there we go. So now we know A and we know B. Okay, if we were drawing our picture, we would say, well, B is 37 degrees and A is 62 degrees. Okay, so there you go. So you'll use the properties of the different theorems to find out these different angle measures. Okay, all right, so let's go ahead and try another problem. So let's say we have this triangle here, and we're trying to find the measure of this angle here, which we'll call C, and this angle here, which we'll call B. Okay, now initially you might be saying, well, I want to do the triangle sum theorem, but we only have the measure of one angle, so we can't figure out B and C without using something else. So if you notice, we have two equal sides right here. Okay, so what that means is we have two base angles that are the same. So by the isosceles triangle theorem, we know that 50 degrees, this angle right here, must be equal to the other base angle, which is C. Okay? Or in other words, C equals 50 degrees. Okay? Now we can use the triangle sum theorem to finish off this case, because we know that 50 plus C plus B gives us 180. So 50 degrees plus C, which is also 50 degrees, plus B gives us 180 degrees. Okay? So B is going to be equal to 180 minus 50 minus 50. If you put that in your calculator, you'll find that B is equal to 80 degrees. Okay? So there we go. We can label our triangle now. So we'll get rid of B and C, because now we know that B is 80 degrees and C is 50 degrees. Okay? So there we go. Now we know the triangle angles from the triangle sum theorem and the isosceles triangle theorem. Okay? Let's try one more just to make sure we got this down so you're ready for the homework. In this case, we're going to be using the triangle sum theorem, but now we have some x's in there. Okay? So we're not given directly what the angles are, but we're given how they relate to x. Okay? We can still use the triangle sum theorem in this case. Okay? We can say that the measure of A and B and C add up to 180, but we'll just replace it with what it says. So 4x minus 4 plus 20x plus 10 plus 18 degrees will give us 180. Okay? Now we can simplify and solve for x to figure this out. So let's combine this 20x and this 4x. Okay? So that's going to give us 24x. Okay? Let's combine the 10 and the 18 and the minus 4. That should give us plus 24. Okay? 10 plus 18 minus 4 is 24. And that will give us 180. Okay? And I forgot to put the degrees marks on all these, but keep in mind they all should have degree marks. Now we can minus the 24 over. So that will give us 24x equals 180 minus 24. You plug that into your calculator. 180 minus 24 will give us a measure of 156. Then the last step will be to divide that 24, or divide the 156 by the 24. And so x equals 156 divided by 24. And that will give you x equals 6.5. Okay, so there we go. Now we can find x from the triangle sum theorem, but before we can finish off, we have to plug x back into the problem to solve for it. Okay, so we're going to take that value we just found and plug it in to the x's in the equation. Okay, so that will give us, for this angle right here, 4 times 6.5 minus 4 degrees. Okay, put that into your calculator, and you'll find that this angle is equal to 22 degrees. Okay, and then this one right here, you'll get 20 times 6.5 plus 10. Plug that into your calculator, and you'll get that that angle is equal to 140 degrees. Okay, and there you go. So now you have found x, so now you can find the angles themselves. Okay, so we still use the triangle sum theorem. We just have to have an extra step of solving for x and then plugging it back in to find the angles. Okay. Alrighty, but that's the homework. You're just going to be using different triangle theorems to figure out these values. Let me know if you have any questions, and thank you for watching.